The question says that determine the slope and deflection of this beam, right? The first step is that calculate the support reaction as usual. Calculate the support reaction, right? Then step 2, you are going to section the beam. Section the beam at a distance x from the left hand support. Steps. Number 1, find the support reaction. Number 2, section the beam. Section the beam at a distance x. At a distance x from the left hand support. From the left the first step is what? Find the support reaction, section the beam xx at a distance x from the left hand support. Number 3, take moment about the point being sectioned, about point x. Number 4, equate. Okay, when you take your moment about the point you've sectioned, denote your moment as m into bracket this, or you use this. That was step 3. Now step 4, equate the moment, which is this, equate this to ei d square y over the x square. Number 5, integrate once. Integrate to get the slope equation. Integrate once to get the slope equation. Number 6, further integrating to get the deflection equation. Then the last one, number 7, substitute boundary condition. Substitute boundary condition to get the value of C1 and C2. And that's all. You want to find the slope and deflection, rather. Your steps, these are your steps. And one thing you should take note is that the steps remain the same. There's no difference. Step 1 up to step 7. That's what you apply for any given question. Now, let's apply the first step. The first step is what? Now, how do you find the support reaction? You are familiar with this now. Find the support reaction. Come back here. Call this place RA. And this place, what do you have? RB. Now, solution. When you are calculating the support reaction, what are the steps? Consider what? Condition of equilibrium, which are what? Summation of f of y equals 0, summation of moment about any point equals 0, and summation f of x equals 0. Now let's consider the first one. Summation of vertical forces equals 0. Force of this nature positive, force of this nature negative. So that would be what? RA plus what? RB negative what? What's the force there? P kilonewton equals 0, right? Which implies that RA plus RB is equals to P kilonewton. Call this equation 1. This is the first condition you've applied. Now, do we have any horizontal force? Do we? Any horizontal force? No. So you are not applying this guy here. Then the next one is what? Summation of moment about any point equals 0. Where should we take our moment?
At B.
At B. So right, taking moment at B, meaning summation of moments at B is equals to 0. So I want us to do this together. That would be what? Yeah, let's take moment at B. What do we have?
So R times L.
Okay, you are taking moment at B. This is your diagram. You want to take moment at B. That becomes what?
Minus P times L over 2.
What does moment means? First time distance. So you are considering these two forces. They are traveling to B. Now let's consider this first one. In what direction and what's the total distance this force covers before getting to B? So what's the direction? Clockwise, meaning positive. What's the force? RA. The total distance it covered is what? L. Meaning that your moment is what? RA times L. You are done with this particular force. Next up, you have this guy here. Now, in what direction is this one traveling to B? Anti-clockwise. Because it is anti-clockwise, negative. Open bracket, what's the force? Force, B. What's the distance it covered? L over 2. Then equates to 0. Then from here, you have RAL minus PL over 2 equals 0. Make RA the summatory formula. That is, RAL is equals to PL over 2. Then you observe that L can cancel L, right? Therefore, RA is equals to P over 2 kilonewton. So if RA is P over 2 kilonewton, you can substitute the value of RA into what? Equation 1. So let's substitute. That will be what? Meaning from equation 1, anywhere I see RA, what will be there? P over 2. Meaning that P, this is equation 1, right? RA plus RB is equals to what? P kilonewton. Now we want to substitute this RA into equation 1. That is P over 2 plus what? RB is equals to P. Now make RB the summatory formula. That becomes RB is equals to P minus P over 2. Take your LCM. Your LCM is what? 2. 2 divided by 1 is what? 2. 2 times this, what do you have? 2P. Negative 2 divided by 2 is what? Mod. 1 times this is what? P. Which is equals to what? P over 2 kilonewton. Therefore, the value of RA is what? P over 2 kilonewton. The value of RB is what? P over 2 kilonewton. So this is step 1, right? Now, step 2 is what? Check your book. What's step 2? Step 2 is section the beam at a distance x from the left hand support. This is P kilonewton. This is A. This is B. What's RA here? P over 2 kilonewton. RB is what? P over 2 kilonewton. This is L over 2. L over 2. And the total length is all meter. Now, the idea of sectioning is that, from step 1, we've calculated the support reaction. Now, step 2 says that you have to section this beam at a distance x from the left hand support. In this case, we have 2 points, right? A and B. Well, either A or B. One is the left hand support, right? The other is the right hand support. Now, check. Which one is the left hand support? Left hand support. You are standing like this. This is your left. RA is the what? Left. This is the right. So what that English means is that you are sectioning this beam at what? At this side. From here to here. Let's say you are sectioning like this. But whenever you are sectioning, make sure you cover the force that the beam is loaded with. You sectioning in this manner is wrong. Are you in me? You must cover the what? The load. You must cover the load that your beam is loaded with. So meaning this is the proper way to section. You are sectioning like this. This is how you denote your section. So you are sectioning at this is section XX. Mind you, you might use another letter. You might say AA. Are you getting me? Anything. You can use 1. But we've said that our step 2 says that section the beam at the what? section the beam xx at a distance x from the left hand support. So we are using xx. We now said at a distance x from the left hand support. You know, this is the left hand support. So meaning from this place that we've sectioned up to the left hand support, the distance is what? X. Step 2, section the beam at a distance x from the left hand support with section. So the distance between this part sectioned and this left hand support, it is what? X meter. Are you getting me? So you've sectioned and you have something like this. This is what? X meter. What's step 3? Step 3 says that take moment about the point being sectioned. So this point that you've sectioned, you are taking moment there. And denote that moment as what? Check. You are told to denote the moment as something. mx. Denote the moment as this. Why? Because this is the point. This point. And what do you have there? The point is denoted with what? xs. So denote the moment. Whatever the moment is, denote it as this. Or you just use something like this, mx. Are you getting me? But I'll use this instead. I will denote the moment as this. So I'm saying the moment is equals to. Now let's take moment. From what we did here, apply the idea here. The way we took our moment here. Come and do it here too. What's the moment? You know, let me bring you back to this. When we took our moment about point B, we consider these two forces, right? We said RA is going to be, and it is going what? In a clockwise direction, positive. The total distance is covered, L meter. I'm done with this RA. The next one is what? P kilonewton. P kilonewton is going like this, anti-clockwise. What's the distance it's covered? L over 2. So that's why I took my moment about point B. Now, apply the same idea. Say you are taking moment about this section part now. This one is going, and this one too is going. Now, for this one now, let's take the moment here. You know, when you are taking moment, it is the force times the distance. Now, what is the force in this case? P over 2. It is RA, but we already know the value to be what? P over 2. What the distance P over 2 covered up to this point you are taking is x. Exactly. In what directions? Positive or negative? Is it going in a clockwise manner or anti-clockwise? So meaning this mxs becomes what? P over 2 times what? X. So you've taken the moment of this particular force to this one. The next one is this guy here, right? Now, in what direction is this one going? Anti-clockwise. What's the force? P. What's the distance?
X over X.
What is distance? This force, this P over 2, it covers S meter to this place, right? Now, this guy, I'm considering this one, this P kilonewton. This is the force, which is P. You already know that it is going in an anti-clockwise manner. That's negative, right? Open bracket, the force is what? P. Now, what is the distance? This force, the distance between this force and this line section is what? Value is x minus L over 2. If from here to here is x, and I know that from here to here is L over 2, then this one will be what? Okay, let me denote this place as C. Let's say you have something like this. Hello, look up this. Let's say you have something like this. Let's say you have something like this. This is A, this is B, this is C, right? From A to B. A to B is what? X meter. Are you hearing me? A to C is what? L over 2 meter. You know, AC plus CB is equals to what? AB. Do you agree with me? AC plus CB is equals to what? AB. Now, what's the unknown here? Call the value of the unknown here. Y. So make Y the surrogate of the formula. What does it mean? It means that CB is equals to what? AB minus what? AC. And what's your AB? AB. X. This is AB. This is AB. The total length X. Meaning that X minus what's AC? L over 2. Meaning Y here is what? X minus L over 2. And truly, by the time you do something like this, L over 2 plus open bracket X minus L over 2. Open up your bracket, right? L over 2 plus X minus L over 2. Observe that this one cancel out and you still have the total length being x meter. You understand? So but you can just look at it from here. If from here to here is x meter and you know from here to here to be L over 2, then this one should be x minus that L over 2. You understand? So from here now, we are saying that the length here is what? X minus L over 2. So if that be the case, the moment will now be P over 2x. We know how you got that one. Negative open bracket. The force is what? P. Now what's the distance? Just solve it, finish. That's what? Open bracket x minus L over 2. And this is step what? Step 3 is what? Take moment about the point being section and denote it as what? MXS. And that's what we've done. Now step 4 is what? Equate the moment to this guy here. This moment that I got here, equate it to what? EI the square y over the s square. Now, meaning that I have EI the square y over the x square is equals to what? My moment. And my moment becomes this guy. Meaning EI the square y over the x square is equals to what? P over 2x minus P all into bracket x minus L over 2. That's what? Step 4. Step 5 is what? Integrate once to get what? Slope equation. Step 6 is what? Further integrating, meaning integrate your slope to get deflection. Now let's integrate. So you can see that these are it work. This step, let me just tell you the trick about this thing, that for any question, any beam, as far as the simple supported you cantilever out, this is the step. You just need explanation. It's still the same idea. Don't worry, subsequently we will solve more questions. Step 5 says that integrate both sides. Now integral EI the square y over the s square is equals to what? Integral all into bracket p over 2x minus p all into bracket x minus L over 2. Any question on that? Now let's integrate. You know, this is a constant. EI is a constant, meaning EI integral the square y over the x square. From the idea of integration, you can split this, meaning integral p over 2x minus integral p all into bracket x minus L over 2. From here, let's perform our integration. This becomes EI the y over the x equals to, let's integrate. You know, p over 2 is a constant here. What is here is still the same as this. You factor out the constant. P over 2 is a constant here. P is also a constant here. Then integration, because that if you have integral x raised power n, the integral becomes what? X raised power n plus 1 over n plus 1. So it's just, that's still the same thing that you are doing here. You are doing a similar thing here. So now from here, it becomes EI dy over the x is equals to p over 2 dot x raised power 2 over 2, because there are, we have an invisible one here. So negative p all into bracket. Now the question is, when you want to integrate this one, am I integrating differently? Like, am I separating x from L? The answer is no. You integrate it as a whole. So you are integrating the bracket together. Right? Meaning from here, let's integrate. What do we have? X minus L over 2 square divided by 2. Any question? No. From here, we now have that. Of course, you add what? C, constant of integration. You know, whenever you integrate, plus C. So this is the constant here. We then have EI dy over the x is equals to px square over 4 minus p over 2 x minus L over 2 plus 6. And this is your slope equation. So this is your slope equation. Now let's get deflection equation. How do you get deflection equation? This is your slope equation. How do you get deflection equation? Integrate your slope equation, meaning you perform your integration twice. We are repeating this guy here, meaning that okay, let's just integrate direct. Since I already know that I want to integrate the slope equation, so as to get what? Deflection equation. So that becomes integral ei dy over dx, right, equals to what? Integral, please call the value here for me. Px squared over 4 minus p over 2 integral x minus l over 2 all squared. Then plus integral c. Hope you are not confused. This is my what? Slope equation. To get deflection equation, what are you going to do? Integrate the slope equation. So I'm integrating the whole of this guy. And this is it here. Now let's integrate. That becomes what? Eiy equals to what? B over 4, which is the constant. Integrate s squared. What do you have? S cubed over 3 minus p over 2 x minus l over 2. Then we integrate this becomes p over 2, which is the constant. Then the way we integrated this guy here, we integrated it as a o. From here we integrated it as a o. So same idea here too. We are integrating this o bracket, and we have 2 there initially. So by the time we integrate, what do you have? 2 plus 1, that's 3 over 3. Are you getting me? Now the constant here, you are going to integrate the constant too. Integral c. What's the value of this integral? By the time you integrate, so I'm not saying that recall. If you have integral 8 under integration, your answer will be what? Let's say you are in integration class now. The question asks that integrate this guy. Your answer will be what? 8x. And if you have 8x, what will happen? Whenever you integrate, what will happen? Plus c. You get? This guy here, I've integrated. I got 8x. Are you getting it? Are you getting it? From here, let's say in integration, we have integral 8. By the time you integrate, what do you have? 8x. This is my answer. But I'm not done yet. Why? Because I've not introduced c. Whenever you integrate, add c. So you are now saying what? Plus c. So it is this idea that we are going to use to integrate this constant. Let's call this constants. Okay? The next one will be d. From here, let's integrate this. That will be what? Exactly. Plus cx. I'm using this idea here. So integrating c, I have plus cx. Plus what again? Plus d. Meaning the new constant. In some cases, you might use c1 here, and this one you use what? c2. Both of them are constants. But let's use c and d. Any questions so far? So this becomes your what? Deflection equation. Check the next step again. Okay, now from here, this is your slope equation. This is your deflection equation. Meaning for this beam, you can find slope across any length. Let's say that the total length here is 8 meters. Using this equation, you can find deflection at 0 meters. You can find deflection at 2 meters. You can find deflection at 4 meters. Are you getting me? Meaning that any length you have to find slope for this beam, you are going to substitute that particular value into the slope equation. Likewise, deflection equation. Let's say the question says that find the slope of this beam at 6 meters. What are you going to do? Find the slope of this beam at x equals to 6 meters. You just put x to the 6 in this slope equation. What if it is deflection? X equals to what? 6 in this deflection equation, and that is how it works. So what we are saying in essence is that with this slope equation and deflection equation, you can estimate the value of slope and deflection across any length of this beam. But you observe something. You have constants there, which are unknowns. You have c and d. Are we still going to substitute the value of any value of x into this equation with this c and d? No. Meaning you have to know the exact expression for c and you have to know the exact expression for d. Now check the next step. The next step is what? So that's where boundary condition comes in. The next step says what? Substitute boundary condition to get constant. And what are the constants in this case? C and D. Depending on how, depending on this place might be your C1 and this place might be your C2. Both of them are constant. And you might decide to use H. Anything. But we are just using what? C and D in this case. Now, the question is, how do I get C and D? To get your C and D, which are the constants? The first boundary condition at X is equals to 0. Y is equals to 0. Number 2, at X equals to L meter. At X equals to L meter, Y is equals to 0. Now, how do you know the boundary condition to substitute? Let's say you are solving your question. How do you know the boundary condition to substitute? As far as simply supported beam is concerned, this is how you take your boundary condition. Check this beam. You need to get this clearly, because this is the stage whereby you need to confirm what will be the value of C and D. And if your conclusion on your boundary condition is wrong, you can never get it. Are you me? After all the stress in solving, you get. Now, please pay attention here. Now, just know that the value of X, the initial value of X, and the final value of X, that's what you are going to use. By the time you check this beam now, in this place, what's the value of X? 0 meter. Right? What's the value of X here? L meter. The total length is what? L meter. Are you getting the idea? At point A, let me call this place point C. At point A, what's the value of X? 0 meter. At point C, what's the value of X? X equals to L over 2. At point B, what's the value of X? L meter. So you are using the initial one and the final one. So for the initial one, meaning at X equals to 0, just now the corresponding value of Y will still be 0. For every value of X, the corresponding value will still be 0. Are you with me? So now, me knowing that X is equals to 0 meter for my first boundary condition, Y will be what? 0. Similarly, for second boundary condition, X equals to L meter, Y will still be what? 0. And that's the boundary condition. So what it means is that whenever you are taking boundary condition, take it as far as simply supported beam is concerned. For cantilever beam, the idea is different. But for simply supported beam, that is how it works. So your first boundary condition, when you are on the initial point of your beam, what's the value of X? 0 meter. And your Y still becomes down 0 meter. You understand? At X equals to L meter, the value of Y is still what? 0.
What did they give us like the value of that?
Exactly. Let's say the total length of your beam is 8. Then for the second boundary condition, X should be what? 8 meter. Y will still be 0. Do you understand? Y will still be 0. Because in this case, we don't have any value of Y, do we? Y will still be 0. Because check this beam. Do we have any value of Y? It is this length that you are relating to the X. We go from your Cartesian coordinates. This is X, this is Y. So if this place is 0, this place is L, you can get the value of L ranging from 0 to L. Yes or no?
Yes.
What about Y? Can you get the value? No, because we don't have any Y figure. You get? So meaning, if from here your total value of your total length of X is 15 meter, your second boundary condition will be what? At X equals to 15 meter, Y is what? Y is equals to what? 0. Only simple supported beam. Cantilever beam, the idea is different when we get there. Let's continue. Let's substitute the boundary condition. We are substituting boundary condition to your what? Deflection.